How do you construct and interpret scatter plots? So a scatter plot is just when you have a bunch of points that you would like to be you'd like to see if there's any kind of a linear relationship between them or any relationship between them at all. So you just have data and you want to look at how that data works. For example, here's some data of time gone by and the height of water. So you could be recording the height of water in like a glass or a pool or a cup or a bowl or whatever, and over time in minutes. We're looking at time in minutes, height of water in centimeters. So at 15 minutes, it is 90. So I go to time, here's 10, here's 20. It's hard to see, but if I go about 15, I go up to 90. So I can put a point there. At 30 minutes, it's at 70. So I go 10, 20, 30. 70 is about here. 45 would be 60. So here's 40. 45 is going to be about here. Here's 60. 75. 50. So 60, 75. Here's 50. No. So 40. I put that at 50, not 60. Maybe up a little bit. And then 50 would be down here a little bit. 90, 40. So here's 90. Here's 40. This is close to a straight line, but it's not exactly a straight line. We just need to plot the points. That's a scatter plot. It's just plotting points for data on coordinates. That's it, right? So they're going to be scattered around. Sometimes they show a relationship. This looks kind of like it's decreasing, which means as the time goes up, the height of the water goes down. So as the time increases, the water height decreases. This is what we would call a negative correlation or a negative association, where as time increases, this decreases. That's negative. Positive would be the opposite. If as time increased, the height increased, that would be a positive correlation. And if things were scattered all over, it would be no correlation. So we have this association. That's the term that we'll probably see. You might also see the term correlation, but positive means the x-axis goes up, the y-axis also goes up. So you might say this could be like family size, right? So as family size increases, the loads of laundry increases. So you might think as the number of members in a family increase, the number of loads of laundry. So you could have those two data points. You might look for like an increasing thing like that. Decreasing, you could look at like maybe like heat use, right? As temperature increases, what happens to the use of heat? It's going to decrease. So decreasing shows as this thing increases, this one goes down. That's a negative association. This is positive. Sometimes there's no association. You might have data points that are just scattered all over the place and there's no actual association. You could have clusters. A cluster is when you have a bunch of data points kind of in one area. This still looks like a negative association. So this still could be, you can have like a negative association with clusters, right? And so that's going to be a linear association, or there might be a line. You can have a gap in your data too, where like there's nothing here, right? There's nothing here. That's okay. You can have gaps. It's not a big deal. And there's different ways to interpret that gap. The other term you'll want to know is an outlier. So when I have all this data that shows a clear positive correlation, and there's one data point that like just doesn't match with the rest, that's called an outlier. And we just kind of like leave that as kind of this off to the side thing. And don't let it affect the rest of this here. And those are just different pieces of information, vocabulary words, on how you construct and interpret scatter plots.